according to the requirement, the number of stages will be used in the multi-stage amplifier, and these stages may be a common base amplifier or common emitter amplifier or common collector amplifier. We may use according to the characteristics of the common base or common emitter, common collector amplifier suitable to the application. So let us once again we'll see the characteristics of three types of amplifiers: common base amplifier, common emitter amplifier, and common collector amplifier. Because they are going to be used as individual stages in a multi-stage amplifier. So in a multi-stage amplifier, so according to the characteristics required, so we are going to use these stages as individual stages, these three configuration as individual stages, these three amplifier configurations as individual stages in a multi-stage amplifier. So let us once again now see the characteristics of these three types of transistor amplifiers: common base amplifier, common emitter amplifier, and common collector amplifier. So first, that is the characteristic input impedance of the amplifier. So input impedance of common base amplifier is very low. Input impedance of common base amplifier is very low because common base configuration, emitter acts as the input and collector is the output. So emitter is heavily loaded, so we have a very low input impedance for common base configuration, and common collector it is medium or moderate. And coming to, because the base is the input and the collector is the output for common emitter configuration, so base is moderately doped, so we have a moderate or medium input impedance is medium in common emitter configuration, common emitter amplifier. And common collector, so common collector, in common collector, emitter acts as the output terminal, and the base is the input terminal, and which is very lightly doped. So we have common very lightly doped base is the input region in common collector, emitter is the output. So emitter is heavily doped, so we have low output resistance, output impedance, but we have high input impedance because very lightly doped base is the very lightly doped. So input impedance is very low in the common base configuration, and it is very high in the common collector amplifier. So coming to output impedance, which is opposite to that of input impedance. So the input impedance is very high in the common collector, but it is very low in the common collector. Similarly, in common base, we have very low input impedance, but we have very high output impedance in common base. So it is in the two. So that is the difference we have to observe in the two transistor amplifiers, common base and common collector. Common collector, high output, very high input impedance and very low output impedance. And common base, we have very high input impedance and very low output, impedance. So common base, we have very low input impedance and very high output impedance. Coming to the phase angle is zero. There is no phase shift in the common base amplifier and the common collector amplifier. We are not going to have any phase shift between the input and amplified output signal. but we have a phase shift of 180 degrees between the amplified output signal with input in the common emitter amplifier. So whenever we need a phase shift of 180 degrees, we are going to use common emitter amplifier. um, but when the application is required with no phase shift uh, between input and output, amplifier required with no phase shift, so we are going to use common base or common collector configuration. Okay. So voltage gain, another important characteristics of amplifier is voltage gain, which is high in the common base amplifier, and it is medium. Voltage gain is medium in the common emitter amplifier, and it is very low in the common collector. Voltage gain is low, almost no gain, unity gain will get common collector. So it is very high in the common base. Voltage gain is very high in the common base, and low medium in the common emitter, and very low in the common collector. Current gain opposite to that of voltage gain. So in the voltage gain, common base we have very high, and common collector we have low voltage gain. Here the current gain is very low in the common base, and that is current gain is unity, and current gain is very high in the common collector. So, and we'll have a moderate voltage gain and current gain in the moderate medium voltage gain and current gain of C amplifier is medium, that is moderate current gain, and voltage gain we will get from the common emitter amplifier. So very low, very high values from common base and common collector, but we have a moderate value of voltage gain and current gain in the both moderate values of voltage gain and current gain we will obtain from the common emitter amplifier. So coming to the power gain is very high because we have moderate voltage gain and current gain. Power gain is the product of voltage gain and current gain. So we are going to get a very high power gain using C, and that is very low in the common base, and it is medium in the common collector configuration. So these are the important characteristics of three types of transistor amplifier: common base, common emitter, and common collector amplifiers. So accordingly, then in the multi-stage amplifier we are going to use these transistor amplifier configurations according to the characteristics required in the application. So from the characteristics it is clear that we have both voltage gain and current gain that is possible with a common emitter, and it is not possible with the CB and CC. So we have a power gain that is possible with the CE, and it is not possible with the CB and the CC. So the CE is the most widely used configuration in the three types. CE is the most widely used transistor amplifier configuration, and the ideal amplifier should have high input impedance and very low output impedance. So this is also an important characteristics of amplifier: high input impedance and low output impedance, high voltage gain and power gain. So all these characteristics are not are not available in a single transistor configuration. We have a power gain, voltage gain, and current gain that is not possible with the CB and CC, but it is possible with the CE. But we don't have a high input impedance in CE, so that is possible with the CC. So low output impedance is with the CB. So but ideal amplifier should have high input impedance and low output impedance, very high voltage gain and power gain. So to have all these characteristics, we need to use we need to go different So since these properties are available in three types of configuration, so we'll use these stages of these amplifiers in as according to the requirement in the multi-stage amplifier. These configurations are used as individual stages according to the requirement. So whenever at the input we need a high input impedance, so we'll go for CC, and at output we should have a low output impedance, so we go for CB, and to have a gain, voltage gain and power gain, we'll use the CE. So that as intermediate stages. So like that we are going to use these stages. These three amplifier configurations as individual stages in a multi-stage amplifier. And see the multi-stage amplifier, and the number of stages 1, 2, 3 and 4 are input resistance, output resistance and voltage gain. We'll consider these important characteristics for the according to the stages. We'll use different configuration amplifier configurations in different stages of the multi-stage amplifier, and we're going to see the input impedance and output impedance and voltage gain of the multi-stage amplifier according to the transient amplifier configurations in different stages of the multi-stage amplifier. So let us first start with two-stage multi-stage amplifier. First stage it is using C amplifier, and second stage it is CE. Then two stages are two-stage cascade amplifier. In the two stages we are going to use a CE amplifier. So CE amplifier so we have a medium both for C amplifier we know the input impedance and output impedance are medium, moderate. So we are going to have a moderate medium input impedance, and output impedance are both are medium, moderate, medium values. But we have high voltage gain because that voltage gain is we have high voltage gain in C amplifier, so the gain of first stage amplified further in the second stage, so we are getting a very high voltage gain at the output of the second stage. Similarly, coming to the configuration multi-stage amplifier configuration, that is CE in the first stage and CC in the second stage. So CE, we are using CE in the first stage, so the input impedance is medium, moderate, because CE is going to have a input impedance is moderate input impedance. So our input impedance of this stage is medium. See, because we are using CE in the first stage, so we are using CE in the first stage, so we have a medium, moderate input impedance, and the CC common collector, we are using C common collector in the second stage. For common collector configuration we have very low output impedance, so in the output stage. So and coming to the voltage gain, so CE we are having a high voltage gain. CE we are studying CC. So CC and for CC and CE stage, CE is the first stage and CC is the second stage. So CE we have a very high voltage gain, and CC is the second stage. So with the same voltage gain provided by the CE stage, we have in the CC there is no voltage gain. So the CC stage in the CCC combination, so we are going to have very high voltage the voltage gain is the voltage gain provided by the CE stage only, so that is only the medium, because the voltage gain of the CE stage is medium. And in the CC second stage we are using CC. In the CC combination, CC combination. So the voltage gain is AV is medium. So and the CE we are using in the first stage and CC in the second stage. So CE we have we have a medium input impedance, and CC we have output impedance of CC is low, and the voltage gain is the gain provided by the CE stage. Voltage gain is the voltage gain provided by the CE stage. So in the second line, these are the characteristics of obtained in the second. These are the characteristics of input impedance, medium input impedance, low output impedance, and high medium voltage gain with the CE-CC combination. And coming to the third configuration, CC-CC, that is opposite CC. The third line, we have configuration CC-CE. The third line we have CC-CE configuration. CC is the input stage, first stage. CC is the first stage. We have very high input impedance. So these are the characteristics of this stage of CC-CE. So we have high input impedance. Input impedance is very high, Rin, because CC is the first stage, and CE output impedance. In the output we have a second stage, we have a CE, so the output impedance R is medium, and because CC we don't have voltage gain, and CE we have a voltage gain that is possible, medium voltage gain is possible. So in the second stage we are going to have the voltage gain with the CE amplifier, that is medium. So this is the third type of multi-stage amplifier configuration. Then now we'll see both the fourth CC and CC both are two CC stages. So when both are two common collector, both two stages common collector, two-stage common collector cascaded amplifier. Cascade amplifier are going to have two common collector configurations. So common collector, the input impedance is very high. So the input impedance of the two stages are going to be very high. So that these are the characteristics of CC and CC. So the input impedance of CC first stage and CC the second stage is very high. So very high, we are going to get a very high input impedance with this type of multi-stage configuration CC-CC, very high input impedance, and the output impedance of the two stages is very low. So the output very low output impedance and very high input impedance where are the properties of CC-CC configuration, and voltage gain is less than 1, because we don't have the gain for common collector. The voltage gain is less than unity, so we are going to get a voltage gain which is less than unity with this configuration of multi-stage amplifier. In a multi-stage amplifier, when we are using two CC amplifiers, so the input impedance, we are going to very high input impedance and very low output impedance, and that voltage gain is less than unity. Is the unity. And coming to the fifth line, fifth 1, 2, 3. This is the fifth. C. All three stages are C. In the fifth we have C, C, and C. Three C stages cascaded one after the other. So three stage multi-stage amplifier, and the three stages we are going to use a common emitter amplifier as individual stages. So we are going to have very high voltage gain. That is possible because we are going to have three stages extremely high. So these are the characteristics of so when now we have three C stages cascaded, three C stages are cascaded. So C, and C. Three C stages are cascaded in a multi-stage amplifier. Then these are like, we're going to get the characteristics like this. So since all the three stages we are going to have a moderate input and output impedances, so the input impedance and output impedance of three-stage cascaded amplifier, cascaded C amplifier, we are going to have a moderate input impedance, since each stage of C amplifier is going to have moderate input impedance and moderate output impedance. So the overall input impedance and output impedance of three-stage C amplifier, three-stage cascaded C amplifier, going to have moderate input impedance and moderate output impedance, but each stage we are going to have a voltage gain, and these voltage gains, moderate voltage gain in the each stage A1 and A2 and A3, and it gets multiplied in the each stage. So the overall gain of A3 total is very high. This is the product of the individual stages. So we are going to get a very extremely high voltage gain with this configuration. C and C, three C stages, individual stages in a cascade amplifier. So we are going to have moderate input and output impedance, but we are going to get very extremely high voltage gain. When the combination is CEC and CC, this is the combination. For this combination, see, first two stages are the CE and the last stage is the CC. In the first two stages we have moderate input impedance and moderate output impedance. Moderate input impedance So we are going to have a medium input impedance in the first two stages, and CC, when this moderate output impedance coming to the output impedance, it become low, because a medium moderate voltage we are getting in the second stage, that the output impedance of the two stages is medium. First two stages is medium, but the output stage of the last stage is very low. So when we have a medium resistance in parallel with the low resistance, so the resultant output resistance is less than the smaller one. So therefore, so we'll get a very low output impedance, because CC is the last stage in the cascaded amplifier. So to have a medium input impedance and very low output impedance, so this type of configuration we will use in the multi-stage amplifier. And coming to the voltage gain for CC stage, it is very high, because in the first two stages we are using CE and CE. So the multiplication of voltage gain is, that is voltage gain is medium in the two stages, multiplied each multiplied by the gain gets multiplied, so we'll get very high voltage gain in CE, CE and CC configuration, very high. The first two stages going to serve the input impedance and voltage gain, very high voltage gain, medium input impedance and very voltage gain, and the last stage CC, that will provide very low output impedance in this configuration of multi-stage amplifier CE, CE, CC. And coming to CE, CC, CE, CE, CC and CE. So we have a medium input impedance, because the first stage is CE, and output impedance is also medium, because it is in the middle. This CC is in the middle, and C is the output stage. CE, both the CEs, common emitter amplifiers, are used in the input stage and output stage. So we are going to have a moderate input impedance and moderate output impedance, and the voltage gain is also, we will get a very high voltage gain, very high voltage gain. See, when CC, because we are using again the product of two voltage gains of the first and last stage, we are going to get very high. The product of the voltage gains in the first stage C amplifier and third stage C amplifier, so we are going to get very high voltage gain in the overall voltage gain is very high, because the product of the first and third stage voltage gains will get the very high voltage gain in the output of the third stage, because the first and third stage we are using C amplifier configurations. So this configuration CE, CC, CE, CE, CC, CE. So we have R, moderate input impedance, medium, output impedance also medium, and AV is also medium. All are medium. Very high. Sorry, both are, sorry. CE, CC and CE, R, RI and R0 both are medium, but AV is very high. AV is very high. Since we have in the first and third stage we have a C configuration, C amplifier configuration. So the product of these voltage gains, the voltage gain will become very high. Like that. when we have the configuration, this configuration CE, CC, CC, C is the first stage, so we have a medium input impedance, and CC and CC two stages. In the second stage we have a common collector configuration, the output impedance is very low, and again in the third stage also we have common collector amplifier, so the output impedance is very low. So when these two R naughts are very low, the output impedance is very low, and we have only one voltage amplification that is possible with the first stage. So we are going to have a medium with the medium output. So with the CE, CC, CC, CE, CC, CC, C is the first, and two second stage and third stage are CC. Then we have RI is medium, and R naught is because second and third stage we are having CC, which is common collector, the output impedance is very low in the the CC configuration that are used in the second and third stage. So the overall output impedance of the this configuration, multi-stage amplifier configuration, is very low, and the voltage gain is that is possible. Voltage gain is not possible in the second and third stages, and is possible only with the first stage. So we have a medium, voltage gain is medium. So this is the combination where medium, very low, these are the properties of RI, R naught, and AV. Medium, that is possible with the CE, and very low output impedance R naught with the CC, CC in the second and third stage, and the voltage gain is medium because of the first stage amplifier we are using CE, that is going to provide voltage gain, a single voltage gain. So in the second and third stage there is no voltage amplification because CC are using. So in the CE, CC and CC, these are the R in, this is R in, R out, and voltage gain AV. And next configuration, that is CE. If you consider the configuration, first is the first CC, and later few stages are CE. First stage is CC, and later we have two configurations, CE and CE. So this is the configuration. With this. So first we have a CC, so very high input impedance, very high, Rin is very high, and in the second and third stages will have uh, the CE configuration, and whose output impedance is medium, so the resultant combination of output impedance is medium, going to be medium. And in the second and third stages we have CE amplifier and whose gain is high, so therefore very high, we are going to get very high voltage gain with this configuration. So this is the configuration with this very high voltage gain. So with this configuration, that is a CC, CE and CE, the characteristics RI, this is the RI, that CC configuration is going to provide very high input impedance, and later two stages CE, moderate output impedance, so that both going to provide R0, this R0 which is medium. And in the voltage gain, coming to the voltage gain, AV voltage gain, so the second and third stage is product of the two stages, second and third stage are going to provide high voltage gain high, so therefore we are going to get a very high voltage gain because of these two CE configurations used in the second and third configurations. Say second and third stage CE amplifiers in the multi-stage amplifier. So now we will see the next configuration, that is a in the input and output we have CC, this configuration. CC, CE, CC. So in the input side we have a CC, so we have a very high input impedance that is possible with this RI, and very high, RI is very high, and the output impedance of the second stage is medium, and it is combined with the very low output impedance of CC. Output impedance of CC is low and C is high, so we are going to get output impedance that is medium. Because in this last stage let us consider the configuration C CC, CC, CE, CC, so CC, this configuration, CC in the input stage, so we have I input impedance, and CC at the output stage we have very low output impedance, and we have only one voltage gain that is possible with the C, so we have a medium voltage gain is medium. So with this configuration, this will get characteristics. And next CC CC CE. With this configuration CC CC CE. So at the output we have a CE configuration, so we have moderate voltage gain, medium voltage gain is medium. These are the characteristics. So CC at the input stage we have very high input impedance, and the output impedance is going to provide by CE, that is medium, and the voltage gain is also provided with the CE, that is also medium. And when we'll use three C configurations, CC, CC and CC, all three configurations CC, then very high three configurations we are going to have very high input impedance, because all the three configurations are going to offer a very high input impedance. So overall input impedance of three stage cascade CC amplifier is very high. So therefore very high input impedance, and very low output impedance, the characteristics of CC in the three stages, and no voltage gain, because the voltage gain of individual stage CC amplifier is less than 1. So the overall voltage gain of three stage common collector multi-stage amplifier is going to be less than 1. This is less than 1. And finally we'll consider the last stage, that is CC CE CE CC. The input we have this stage. So at the input we have CC, so we have high input impedance. In the middle two stages are going to give very high voltage gain, very high voltage gain, and at the last stage we have CC, that the output impedance is low. So this is the ideal characteristics. So in the first stage we will use a CC, and in the middle stages we are going to use CE in the middle stages, and in the output stage again we will use CC. So an ideal characteristics, this is the ideal characteristics of a multi-stage. So a multi-stage amplifier should have a high input impedance, very high voltage gain and current gain and power gain, and a very low output impedance. That are all these are possible with this configuration, that is CC CE. The voltage gain, current gain is possible in the middle stages, and in the output stage again we'll use CC. So R0 is very low, and because of these two we are going to have AV and AV. Power gain is very high, voltage gain is very high, and with this we have RI is very high. So very high input impedance, very high voltage gain and very low output impedance. These are the ideal characteristics of a multi-stage amplifier that is possible with this configuration. Multi-stage amplifier. So today we have studied the characteristics of a multi-stage amplifier. Tomorrow in the next class we'll see the gain and the frequency response of a multi-stage amplifier. So a multi-stage amplifier practical consists of the first stage is usually required to provide high input impedance, so we are going to use CC, and that is going to also offer the first stage high common mode rejection, with the CC configuration. In the middle stages we are going to have voltage gain. Majority of voltage gain and current gain is possible with the middle stages. So the conversion here, the voltage gain is possible with the middle stages, and conversion of signal from differential mode to single-ended mode, shifting of the DC level of the signal, that is possible with the middle stages. And the last output stages going to provide a low output resistance in order to avoid loss of gain and provide current required by the load. So we need power amplifiers are the characteristics of low output impedance, and high current is required, and low output resistance in order to avoid the loss of gain, and also provide high current required by the load. So we need a power amplifiers in the final stages of the multi-stage amplifier. We'll stop here today.